Okay, let's
Yes.
start. So our first question is just a long statement. These questions are of different type. Here they will not provide so much data, but they will give you some hint or the direction in which you need to flow or you need to move and solve the question. As here in the question number one, they are saying that how far can we jump? That is the question. And about this question, he will provide a little bit history. For example, this equation questions evaluates your ability to look at some problems with different perspectives. So the lesson or the thing that we will gain in this question is that to see a question from different perspectives, it will sequenced in four parts. Let us check which are these four parts. First one, dimensional analysis. In the first case, we will use dimensional analysis. If you're talking about the jump, in case of jump, if you have observed racing team jumping, they move like a parabolic path as a projectile move. And if we are talking about the projectile or the parabolic path, then some things which should become in our mind, which should describe actually the projectile motion. For example, time of flight, trajectory, range, maximum height. These are the important things that describe the projectile motion. And our jumping position is also describe the projectile motion. Here you can see if this person is jumping, then actually he is performing some type of low height projectile motion. So here we need to also discuss some point of projectile motion. So first part, dimensional analysis, and much more in our past modules we have discussed about the dimensional analysis just by using the dimensional rules to calculate the formula for some specific term, for example, for the range or for the time of flight. Actually, we will do in this part. Is used to identify the key features of analyzed motion based on free body diagram. Second part, a vector based equations is solved complement the output of the first point. So in the first point, first of all, we will discuss it dimensionally, some specific terms, for example, as time of flight or the range according to the dimensional rules. And in the second case, we will use the vector rules to solve such type of equation to find. Okay, third part, the problem is now solved thanks to the work energy theorem. The most different thing that we need to have a touch with the projectile motion is actually a work energy theorem. In work energy theorem, in the previous classes, in the previous lessons, we have discussed projectile motion, but we did not coincide the work energy theorem with the projectile motion, and we did not discuss the energy of moving projectile. But here today we will actually need to coincide the work energy theorem with the projectile motion in this question. So the fourth part, your solution serves to realize predictions on real life example with specified parameters that are for example, radius, mass, velocities. Okay, these four parts are actually a little bit review about our actual questions. They're just telling to us that which possible steps are here to solve this question, how far we can jump. So let us check. And here we are having an example here. Simply you are observing a child is actually trying to jump and getting a range that is actually horizontal distance, so, as a child, you probably ran into the following question: how far can I jump? That is the question. Such question motivated the creation of the Olympic discipline of the long jumps. So, if you're talking about how far you can jump, the initial thing that you should came in your mind is your speed, initial push of the jump, and the second thing on which angle you will jump. If you will take some higher angle, then your range will be squeezed. But if you will take some smaller angle for the jump, then your range or the vertical distance covered during this jump will increase. We will also discuss this in this question. To identify how far someone can jump, we can start by looking at the motion of simple projectile. Here is an example figure for a long jump where you can see that center of mass of the athlete is located on a parabola for the whole jump. So if we have seen that this path is actually resembled like parabolic path, not having a much height, low height parabola you can consider. Okay, the key physical quantity in this problem is range, and that is also mentioned here. You can see range. The world record is just that is not of our concern. He is showing some record of the USA and some record of the Soviet Union, but that is not of our concern. But he wanna show that it is actually some type of the game that student or the children perform in their college or student life. Some type of the jumps, for example, higher jump, lower jump. That is some type of the game, but that is not of our concern. The maximum jump that is gained till now is from the USA record, that is 8.95 meter, and for the Soviet Union for the female is 7.52 meter. That is actual record till now, and none has broken till now. But that was actually a little bit just for the information about the long jump, but that is not concern to solve our problem. Now we are starting our question to solve the problem. Okay, first part in the dimensional analysis, as we have divided here four steps to solve over these questions. The first part is actually dimensional analysis of this question. A priori, could you list the different relevant physical quantities that range could depend? That is our first part. In case of the dimensional analysis, in the first part one, we need to check on which possible factors range depends. Okay, a little detail he is giving to us. Name them and identify with their physical dimension. We also need to write their name, and also we need to write their physical dimension. And hint is given to us. It does not depend on the height of athlete. Such height would be noted as with the physical dimension of length L. You can use the usual symbol M standing for mass. These are actually basic information that already we know. Length for L and time for T. So first of all, we need to consider that a range is actually itself is a length, horizontal length, and possibly it can depend on the initial speed. First factor we can write here, initial speed on which it can depend. Speed V naught, initial speed. And in the question, he is also saying to us that we need to write their dimension and name. So we have written its name, and for the dimension, we know speed has the dimension LT inverse 1. L stand for the length, T stand for the time. And second thing that we can consider is actually gravitational acceleration G. And if we will write it dimensionally, we know for the acceleration unit is meter per second square, then its dimensional formula will become LT inverse 2. These are the two possible factor on the range can depend. And here a third factor that is actually dimensionless is theta. So it don't have any dimension, so it is dimensionless. Shortly, I am writing D less. But later we will include it. It will not be the part of the dimensional analysis, but to complete the formula, we will give a touch of this angle. Okay, so in the first part, he was saying these things that could you list different relevant physical quantities that range could depend. So we have shown here different physical quantities. First one, speed. Second one, gravitational acceleration. Third one, angle theta. And what you need to do, name them and identify with their physical quantity. So name them. First one is speed, whose dimensional analysis is LT inverse formula, and second one is gravitational acceleration having the dimension LT inverse square, and third one is a theta that is actually dimensionless. So till now we have completed our first part. Let us check the second part. In the second part that he is saying, based on the dimensional analysis, write down an equation of the range. So we have already done our calculated many formulas in our previous classes by using the dimensional analysis, and today we will do the same thing. So in the first part we have considered that dimension is actually range is actually depending on the speed and gravitational acceleration and angle theta. If range is depending on these two factors, then consider range is actually directly proportional to these two factors. Initial velocity v naught and gravitational acceleration g, and consider they are having the power as an exponent a and b, where a and b are the constants. You can say that is it is equation a that we will use at the end after calculating the value of the A and B. So a range already we have discussed that a range is actually the length. If it is actually the length, then it will have the dimension of length. So we can write it like this: R is having the dimension length L. So now we need to compare the left and right side of this equation dimensionally. So as a range is length, then we can write range as a L, as the second term is the velocity having the unit LT inverse dimension LT inverse 1. You can write its exponential power A, and second term is acceleration gravitational LT inverse 2 to raise power B, and L we can write its power unit 1. So let us simplify. We need to give the power to each term within the bracket L to raise power A and T to raise power minus A. Similarly, in the second bracket, L to raise power B and T to raise power minus B, 2B, minus 2B, because here we have LT inverse 2. Now, as they are in the product shape, we can write them in the same bracket. Then our relation will become L multiplied by L. Both power will be added. So A plus B, L raised power A plus B. Similarly, for the time T, minus A minus 2B. And close the bracket. On the other side, we have the only length L, whose power is just 1. Now, what you need to do in the next step, you need to compare the left hand side power exponents and the right hand power exponents. So, as on the left hand side, we have the factor length L having the power 1. On the right hand side, we have the factor L having the power A plus B. So, after comparing their powers, we can make an equation from their power A plus B is equal to 1. And you can see on the left hand side there is no factor of the time, so we can write the factor of time A minus 2B is equal to 0. Or simply you can write it A is equal to minus 2B. Now what you need to do, you need to write this value of A is equal to minus 2B in our first equation. Then our equation will become minus 2B plus B is equal to 1, and after simplifying, our value of b will become b is equal to minus 1. So that is the value of b, minus 1. Now what you need to do, you need to replace that value of b in this equation. Then our relation will become a is equal to minus 2 into minus 1 will results minus minus plus a is equal to 2. So value of a is equal to 2. Till this step we have calculated the value of the exponents. Value of the b is minus 1 and value of the a is plus 2. Now what you need to do, putting these values in equation a. Putting these values in equation a. So what is our equation A we have made initially? You can see now we need to put these values in this equation. Then our equation will become R is proportional to V to raise power A. A is having the power 2 and B is having the power minus 1. So G to raise power minus 1, and you can write this equation. R is proportional to inverse value will move in the denominator, then our equation will become V naught square divided by G. And if you will remove the proportionality constant, then our equation will become R is equal to K of proportionality constant. We are removing the just proportionality, K V naught square over G. And if you want to include the angle factor, which is not the part of dimensional analysis, then our actual equation for the range will become V naught square by G sine of 2 theta. That is our actual equation. But you know, dimensional analysis is directly coincide with the unit. And here, so we are considering theta is actually dimensionless. So if we will talk about the unit, then according to the unit, our this equation is correct by we have proved through the dimensional analysis. So that was actually our second part. Based on the dimensional analysis, write down an equation for the range using the quantitative quantities you listed in the sub question 1. So in the sub question 1, here is a sub question 1. In this sub question, we have listed these quantities, and we have used these quantities in the part 2 as here from equation A you can see. And from this we have derived the relation for the range, as that is here you can see V naught square by G, and after including the angle it has become V naught square by G sine 2 theta.
Sorry,
Let
can
us
I
check
have
its
one question? In the answer where it's like R equals, why is there a K? I did not
K is
understand.
actually okay. You need to understand. If you know about the basic mathematics, two things are possible, but in some proportion. And here we are removing the proportionality constant from here and putting here equality. Then we need to introduce a proportionality constant k, which will make them equal. In some cases, two things are directly proportional, but they are not increasing or decreasing in the same proportion. Some quantities increase in more magnitude, and some quantity can increase in less magnitude. So to make them equal, we need to introduce some proportionality constant so that mathematically these equations can be equal to each other. Is it clear?
Yes, it's clear.
Okay. So here we have the third part. Based on the dimensional analysis, write down an equation for another physical quantity, that is time of flight. This time corresponds to the duration of the jump. Here, from the dimensional analysis, we need to discuss the time of flight. If we are choosing the method for the dimensional analysis, for that purpose again we need to consider some quantities on which time of light can depend. And as we are still solving a single question, and in the start we have considered some physical quantities. Here you can see speed, gravity, and theta are those quantities that we have considered on which a range can depend, and also we can consider these quantities on which time t can depend. So we can write time t is directly proportional to these quantities. V naught is the initial velocity. We can write V naught to raised power a, and g, which is a gravitational acceleration having power p. You can say this is our equation A. Now we know their dimensions. So we need to compare the left and right hand sides by the dimension. So for the time we know we have the dimension t plus 1, and for the velocity we have the dimension L t inverse 1, and as we have here introduced the power a as an exponent, and similarly for g, L t inverse 2, and here we need to introduce the power b. And similarly what we need to do, we need to multiply the powers exponents internally, then our equation will become L to raise power a, t to raise power minus a, and on the other side L to raise power b, t to raise power minus 2b. In the next step, what you need to do, you need to multiply these values internally. Then our equation will become L to raise power a plus b, and t to raise power minus a minus 2b, bracket close, while on the left hand side we have only the factor time having the power 1. Now you need to compare powers of the both side, as on the left hand side and right hand side we have the factor time t. So we can write our equation minus a minus 2b is equal to 1. And for the length we don't have any factor on the right left hand side, so we can write a plus b is equal to 0, and also we can write it a is equal to minus b, and also we can write this equation value of a in our equation first. Then our first equation will become, we are putting actually the value of the a, minus into minus b minus 2b is equal to 1, minus minus plus b minus 2b is equal to 1, and you can write it minus b is equal to 1, then b is equal to minus 1. And now what you need to do, you need to put this value of the b in our this equation. Then you can consider a is equal to minus into minus 1, then it will results plus 1. So value of a is here plus 1, and value of b is here minus 1. Now what you need to do, you need to replace these values in our equation a. Then our equation a is here, yes. After putting the values, then our relation will become t is proportional to v to raise power 1 and g to raise power minus 1, and we can write this equation t is proportional to v over g. and that is actually dimensional analysis. Again, I want to remove this proportionality. As I will remove this proportionality, then some proportionality constant is necessary to put it here, is equal to k v by g. And that is actually the relation for the time of flight. And already I have told to you the importance of this proportionality constant. For example, I am writing here some quantities just to explain it. I am writing here 4 is equal to 2. You will say, no, sir, it is not correct. Okay, fine. I am writing here then another quantity that, for example, if I will put here some constant k and give the values to this constant is equal to 2, now you will agree that, sir, now it is fine, because when I will multiply or place the value of the k is equal to 2, so 2 multiplied by 2, then equation will be the satisfied. So that is actually the requirement of this proportionality constant. Okay.
Yeah.
Okay, so our final equation from the dimensional analysis for the time of flight t is equal to k v over g. But whenever we will introduce the value of the sine theta and constant, then this relation will become 2v naught sine of theta over g is equal to time of flight. That is actual relation for the time of flight, but as our dimensional analysis actually does not discuss the angle, and it only discuss the some vector quantities that are having some proper units. So here, for the from the dimensional analysis, we have this relation. But as we will include the angle theta, then our final relation for the time of flight will become t is equal to 2v naught sine of theta over g. Is it clear?
Yeah. So always when you include the angle, you put two theta.
Yes, 2
Okay.
theta, 2 sine theta, 2
Yeah.
sine theta. Okay. So based on so we have completed our first part, that is a dimensional analysis, and
Mhm.
I need to raise these to have some space. Okay. Okay. So I want you need to have a look on the questions that I have made dimension analysis a little bit, just within a 1 minute. You need to check it.
Mhm.
Range is actually a length having the dimension L. Fine. It depends on the velocity. It depends on the angle theta. It also depends on the gravitational acceleration. So as it is, so as they have told to us that we need to write these if in their dimensional shape, so we have written them in the dimensional shape. And in the first part, they told to us to measure the range by using the dimensional analysis. So we are measuring, and these are the factors that we have considered. Now we are considering that range as actually depending on this factor. So it is directly proportional to the initial velocity and gravitational acceleration g. So dimensionally, we can compare these values, as you can see, and mathematically, we are multiplying the exponents from the power of whole bracket to the individual variable, and multiplying mathematically their powers of the similar variables will be added, and now we are here to compare the exponents, and during their comparison we have calculated the value of b and a. Now what we need to do, we need to put these values in equation a. So after putting these values in equation a, our equation has become like this. And after removing this proportionality, now we need to introduce a proportionality constant, that is k. Alphabetically you can say something other, for example abcd, whatever, because it is a constant. So if you want to include the angle theta, then our actual relation will become, but dimension analysis does not support this. And in the next part, you need to calculate the time of flight. As you can see, time of flight and range, both are depending on the same factors. For example, on the gravity and on the initial velocity. So here we are again choosing these values. T is proportional to V naught to raise power A, G to raise power B. And dimensionally, we can write time T is represented by T velocity by this and G by this. As we are calculating the time of flight is actually from the point of projection to the point of landing. So here we can write by comparing the left and right side, T is equal to LT inverse to raise power A, LT inverse 2 to raise power B, where exponents A, B are constants. So simply multiplying internally, so similar variables will have the power sum. Here also you can see, and comparing the exponents, a plus b is equal to 0 because there is no factor on the left hand side for the length. There is only factor which is for the time. So after comparing the value of the time, we have minus a minus 2b is equal to 1. So putting in second equation, here is our second equation, a is equal to minus b, and we are putting in second equation. Then our equation will give, and finally we have the value of a and b, and putting the values in equation a. And now after putting the value as it is in inverse, so it will move in the denominator. Our relation has become T is proportional to V naught over G. And after removing the proportionality, we need to introduce proportionality constant K. And if we include the angle theta, then our equation will become some type like this. And time to reach the maximum height in this case will be V naught sine of theta over G. Is it clear?
Yes, it's clear. What quantities would like the swing of a pendulum, what would that like depend on?
Hmm?
Like, when a pendulum swings, what would that
Okay,
depend
okay.
on?
So in case of the pendulum,
Yeah, like
hmm
the g, and would it depend on velocity? Like, if I were to do a
okay,
dimensional analysis for that.
okay. For the in that case, we will discuss actually a time period. You know, time period depends on the length of the pendulum and gravitational acceleration g only. It did not depend on anything, but it is actually an upcoming question in which we will discuss in detail.
Okay, good.
Okay. Okay, okay. As I think the exam is coming close and you are in the hurry positions,
Yes.
just you want to cover everything within a few minutes.
That would be nice.
Okay.